Hi! This instructional video is about multiplying polynomials. In this case, we're going to work on multiplying binomials. And the way this is set up, this is called a square of a binomial. If you have a binomial, and if you take two of them, that's a perfect square. So when it says to find the product, it means to rewrite this binomial that's in square form as two separate binomials. So it's x minus 3 times another x minus 3. And then you're going to apply the FOIL method, the distributive property of the two binomials. So you go x times x is x squared, and x times negative 3 is negative 3x. And of course, the second term of the first binomial, you do the same thing. Negative 3 times x is negative 3x, and negative 3 times negative 3 is positive 9. And when you combine the two middle terms, negative 3x and negative 3x, they become a bigger negative, negative 6x. And we have an x squared for the first term, and the last term, which is plus 9. And so this is called a perfect square trinomial. Now try to catch the pattern as you do the number 2 on your own. Okay, so you take the square of this binomial and write it 2 separately. So we got x plus 7 times another x plus 7. And you do your FOIL method, x times x is x squared. X times positive 7 is positive 7x. And then this second term, positive 7 times x is positive 7x. And positive 7 times the positive 7 last term is positive 49. Once again, when you do the FOIL method, you combine the middle terms, and positive 7x becomes positive 14x. Bring down the first and the last term, and you have a perfect square trinomial. Are you seeing a pattern yet? Okay, one more time. Now number 3, let me demonstrate that one, because we have a coefficient other than a 1 on this binomial. So it's a square of another binomial. So we're going to write the two binomials side by side, and then we're going to do the FOIL method again. And I'll go a little faster. Okay, 2x gives me 4x squared. 2x and 1 is 2x. 1 and 2x is 2x. Always the same in the middle. And 1 and 1 is plus 1. The last term is always a plus. Always a plus. Always a plus and a perfect square. So in this case, you get 4x squared plus 4x plus the 1. Are you seeing it yet? And now see if you can use that pattern, if you recognized it, to evaluate this square of a binomial. Okay, so if you said 4x minus 5 times another 4x minus 5, that is the correct setup. Even faster now. 4x and 4x, 16x squared. Negative 5 and 4x is 20 negative. That's a 20 negative. So it becomes negative 40x. And negative 5 is positive 25. Did you see that? Yeah. Same thing here. Now this is not in standard form, where the degree of exponent height is in the front, but it doesn't matter. Once again, 3 and 3 is 9. 3 and 4x is 12x. 12x is 24x. And 4x and 4x is 16x squared. Now, if you want to put that in standard form, of course, you could write that as 16x squared plus 24x plus the 9. And in algebra, it's a common courtesy to write everything in standard form. Now, finally, you. Okay, now you said 2 and 2 is 4. 2 and negative 5x is negative 10. And another negative 10 is negative 20x. And negative 5 is positive 25x squared. You don't even have to set it up as the way we did over here. And finally, in standard form, that's written as 25x squared minus the 20x, always carry the sign in front, plus the 4, and there's your perfect square trinomial. In this case, this is called the difference of a binomial, or sometimes we call it the conjugate of a binomial. And something magical happens when you do this special product property. Let me demonstrate with number 1. And once again, like the other instructional video, see if you could catch the pattern. When you do the FOIL method of these two binomials, x times x is x squared. X times negative 2 is negative 2x. Positive 2x times x is plus 2x. And positive 2 times negative 2 is negative 4. Anytime you do the FOIL method, or distributive property of two binomials, you have to combine the middle term, and in this case, they cancel out. They're the additive inverse. So you got x squared minus 4. Why don't you try this one? Okay, so you said x times x is x squared. X times positive 3 is positive 3x. Now this one, negative 3 times x is negative 3x. And negative 3 times positive 3 is negative 9. Combine the middle term, they cancel out. X squared minus 9. Yeah, I hope you're seeing a pattern here. So let me go a little faster to model number 3 for you. X times x is x squared. And 8 times negative 8 is negative 64. What? You didn't even do the middle terms. Because I know that they're going to cancel out each time. And this only works if it's a difference of an identical binomial. Now you try this one. Alright, if you said 2x and 2x is 4x squared, and you said forget the middle term, because they'll be opposite, and you said negative 1 times positive 1 is negative 1, you'll be right. Some voodoo magic? No. Difference of a binomial. Now this one and that one. Why don't you try it? Okay, so 5x and 5x is 25x squared. Forget the middle term because they cancel. And 3 and negative 3 is negative 9. Oh, you're on fire now. Check this out. 7x, 7x, 49x squared. Negative 2 and positive 2, negative 4. And please note, they're always perfect squares. And they're always minus. Okay? Perfect square leading coefficient also. And the x squared is always, well, square. Okay? There's your magic. Enjoy.